Hearing none, let us jump into things. So what I'm going to do today is I'm going to kick off a sample project that we can work on throughout this course during these sessions and introduce different features that follow along with the content of this particular week. And this week, the main two things are props and state. I think those are the things that trip people up the most. And once we figure those out, things will be relatively smooth sailing. So what I've done is I have created a project in GitHub that each week I'm going to create a branch on and write some code, and then we'll push it up so you have a reference if you would like to have it for another day. So I'm going to go and grab this link for you. Actually, I think we can just do this. There we go. So this is the link to the project. Right now, if you look in the master branch, I need to close this. There should be nothing in there. We'll put some stuff in there. I'll merge it into the master once we're finished. But for now, if you go into your master branch on here, you can clone this if you want to follow along. If you don't want to follow along, that's totally fine. Cool. So I'm going to open this in VS Code. This is an example application. It still has all the stuff. I literally just bootstrapped this from Vite, and that's all we did. Step one, get rid of everything that's in here. And we'll go from there. All right. Everything is gone. So let's do this. Let us work on a project where we're going to create a really sort of dumbed down version of a shopping platform. So I want to be able to go on there and I should have a list of all the different products I can buy. Eventually, I want to be able to have multiple pages in my products table. Eventually, we will pull our products from an API. Right now, in your to-do list application, everything is hard-coded. We've written 3 to-dos. That's it. And this week is when you start to add more of them with the form that we're going to work on. But eventually, we want to go even beyond that and pull it from some external source, some server that we've written somewhere else, and pull all of those into our application. We probably wanted to make it look pretty, so on and so forth. There's lots of really cool things we can do here. But first thing we need to do is we need to actually put together a proof of concept or a minimum viable product. Those are 2 words you might hear very often, but generally that means just the bare minimum to make it work and show that it works. And then we can add features from there once we have our base. So what we're going to do today is we're going to create our products table, create some dummy products, show those products in the table, add a search bar for some products. All right, I'm going to do as much of this as I can in an hour. We might run a little bit overboard, but we'll cover props and state as part of this. Cool. So first things first, we need some dummy data. I'm going to put this in a separate file just so that I can keep everything separate. We're literally just going to call this dummy data, and this is just going to be a JavaScript array. And so I don't need to make this a JSX file because it's just JavaScript. There's no layout, there's no React elements to it. So if you haven't fully grasped what this export does, export makes your code available to other files. It exports it, and then other files can import it. This default keyword means there's only one thing that we're exporting from this file. So when you import it, it's just going to import that thing, and you can call it whatever you want. You can also export multiple different things from a file. and give them particular names. So I could export like this, and now in another file, I have to import specifically app from whatever this is. We're not going to do that though. We're going to leave this as is. Most of the time for React components, we're only exporting the component, and so this default is great. But up here in our JavaScript, we still need to export something. We need to export a data array. And we're going to just add a bunch of products in here. Someone shout out something that a product should have, some property that a product should have. I would say it should have a name. What are we actually selling? I think it should have a price. Maybe it should have an image. Anything else that would be good here? Yeah, picture is a good one.
Description.
Yeah, description's great. We definitely want a description. And maybe we want a
availability.
discount. Say it again?
Availability, whether it's in stock or not.
Yeah, that's also a good one. If I can actually hit enter on my keyboard. I also saw an ID property in there. That's super important. We have to be able to easily reference this piece of data everywhere in our application. So an ID is going to go up there at the top. For the purposes of moving through this quickly, we're going to start with just these at the top, these bare bones. And then we can add some other properties either today or later this week or next week, depending on how much time we have. But let's add maybe like 3 products for now. Let's make this food. We're gonna make like an Amazon Fresh here. Someone give me your favorite food.
Cheese.
Cheese. I like cheese. All right, we'll sell a cheese block. That's number 1. Number 2, I know wine goes really well with cheese. I'm not a wine person, but we'll do bottle of wine. And number 3,
Olives.
olives. I'm sensing a theme here. Cool. What else did we say? We need a price. We're gonna make this a funky number just for fun. We're gonna say this is $8.37. And let's make this a number since it should really be a number. And we need a picture. We'll just Google images this. That'll work. An image. Copy image link. Cool. Oh my goodness. This is enormous. All right, maybe choose a different one. Open image in new tab. Copy image link. Maybe this one will be smaller. Cool, that's more reasonable. All right, and then price for bottle of wine. This is going to be $5,000 even. And olives, we'll make this like $3.75. Open image, new tab. Copy image link. Oh my goodness, it's so long. Holy crap. Oh, that's not a valid link. That's let's try another one. Copy image link. All right, I'm not going to do this right now. We're just going to leave these without a picture and we'll come back to it. There's more important things to do here. Cool. So we've exported this data and now we need to start using this data somewhere. So if I wanted to create a product in the way that we've done in previous assignments, I would do something with my dummy data. What function would I need to use here if I want to turn all of those objects into like a list component? In our homework assignment, we did an unordered list, and then we did our to-do lists, and then we used a function. Do we remember what function? Map.
Map.
Exactly right. So we have our product here, and then we're going to return a list item or something in here. Let's not do this. Let's make this officially a table, which is where we're going anyway, rather than an unordered list. And inside of our table, we have a table body element. And inside of that, we have table rows. And then we have table data, so on and so forth. This is the structure of an HTML table. We're going to replace this table data with our products in there. Products or dummy data.map product becomes a table data element. And you'll remember that we need to give it a key anytime we map to a list of things. So we're going to give it a key property, and someone very smartly said we needed an ID on our product. Well, we have an ID, so we can use that as our key. And then inside of here, maybe we'll do an image tag with source equal to product.picture. And then we need our product.name and our h4 product.price. Did we put anything else in there yet? Nope, that's all we got. Cool. I can run this code right now and it should show up in our browser, no problem. This will look very similar to what we've already done as part of our homework with our to-do list application. Oh, these images are very large. And it's not quite the right format. So let's fix this a little bit. I messed up the layout here. And let's add some CSS really quick just to say images should be heights. Max height of 400 pixels, max width 400 pixels. There we go. That's a lot more reasonable. Cool. So we have our products here. It's a list. We don't have an image for those other ones. Now, this is great, but I think that this table should be its own component. Eventually, we're going to put more stuff in our page. Like we want to have our search bar at the top. We want to have the little buttons at the bottom that let you change pages. Therefore, this table, which has a lot of functionality to it and will have things inside of it, we need to extract to its own component. A component generally should be a singular unit of code that has what you're actually rendering to the page, and it has behaviors that pertain to specifically that component. So behaviors that might relate to this table are, let me change to a different page. Let me filter out my table contents based on what I'm searching for. Those should not affect anything else in our application. They're only related to the table component itself. So this is a really good candidate to extract it to a separate component. And that way we can have our app be a composition of the table, the search bar, the footer, all kinds of other stuff in there. So let's do that. Let's create a products table. component. And anytime we create a function or a component rather, we need to return some JSX, which will be something we'll fill in very shortly. And we need to export it so we can use it in another place. Cool. So we have our products table, and now we can use our products table in here as another component. All right. So here's the real problem. The problem is our data currently, we're going to say exists in our app.jsx. In the end, it doesn't really matter in this particular case because our data is like in a different file entirely. And so we could just import it if we want to into our products table. But we need something to hold our data as the source. So eventually this data is going to change. We might remove products, we might add new products, we might search, which filters down the products. If those products live in products table, is anything from our app component going to be able to access them? The answer is no, because in general, data needs to flow down the component tree, and callbacks are the way that you sort of pass actions that go back up the tree. So if I have a tree of components, and let's say my top level component is this app component here, and inside of app, we have a products table, and we have our search bar, and we have our footer, and so on and so forth. If I put my data in here, then I can't add to my data or interact with it from search bar. Or maybe I want to add a new product. Well, I need some way to add to that piece of data, but this component is completely unrelated to this component. Only app knows that this component exists. It's not part of the same tree at all, so I cannot pass data between these two no matter how hard I try. So with that in mind, we generally want to put our data in our top level components and pass our data down into the components that need it. So we pass our data into our form, we pass our data into our table, which allows us to access the data from both places. In this case, we would maybe be using the most recent one and keep it in our search bar. Or up here, we're just going to render them all to the page. And so our data will also need to go into our products table. So our data is going to exist up here. We're just going to define it. And then eventually we want to pass this data into our products table. And the way that we do this is through properties. So big lesson number one for this week. If I want to take data and pass it to a child component so that child can access it, or to multiple different children, you need to declare a property of that component and then give it a piece of information, whether that be a string, a number, an object. You can pass anything as a property. You could pass another React component as a property, I'm pretty sure, or something like that. Like this is valid. But in general, you'll be passing a piece of data, or as we'll see in just a little bit, a callback function, which allows you to perform an action. Maybe I have a function here. And I want to be able to use this action from my child component. Well, what needs to happen is I need to pass it as a property to my child component. This is passing a reference to this function. It's not calling the function. It's just sort of passing the location in memory where that function exists and we can call it. And then my child component can then invoke this function, which calls it up here. This is where the function exists. So those are the two ways that data flows. Data flows down to our child component through properties, and then we can pass it functions, which allow us to do something at the parent level from child. The child is calling the function, and then the parent does the thing, which oftentimes will interact with the data as well. Maybe in this case, we want to add to it or something like that. Is that clear? What this flow of data is. We haven't really talked about how props work on the other side, but in general, this is how you would pass a property to a child. It's a name of some property and then a value that you pass to it. Any questions here so far? All right. Let's do the other side of things. So now I've passed this as a property. I want to access my data in my products table. So this table is going away. And this table should exist in this component instead. But this doesn't exist because we haven't imported it. So how do we get this data down here? Well, every single React component accepts a single object, which is a bundle of all of the properties that you passed to that component. So this component has two properties that I gave it, products and say hello. Those are two things that I defined. And I can pull those out of this object in order to access them. So over here, I can say, let my products equal to props.products, and let say hello equal props.say hello. And Vite is going to try and be really helpful and say that you haven't validated the types of all the data in here, which we're not going to do yet. That's a ways away. So for now, I'm going to go into my rules. And we're just going to turn that off. In the future, we'll use a library called prop types or TypeScript in order to make sure that the data in here is what we're expecting, and we're only using the data that exists in this object, because right now this object is invisible. I know generally what I pass to this component, but I could pass literally anything I want. There could be any amount of data in here. And I might just like make a typo because I don't remember exactly what I passed to this props object. So there are libraries that allow you to verify what data is in there. So let's do this. Let's console.log props, my products, and say hello every time that we use this products table. And dummy data, we're going to get rid of that. That does not exist, and we're going to use my products instead. Map those to the page. Cool. So I refresh. I still see all my things in here, which means that it probably worked. I'm going to go into my console and see what we printed out. So if you remember, we printed out the properties object, which is a JavaScript object, just keys and values, and the two properties that I expect to be in there. Let's also print out this other products, non-existent. This is a property that does not exist. I did not pass it, and therefore it should not be real. Can't spell. Cool. So first thing in here is an object. This object has two properties, products and say hello. Say hello is a function, which is what we expected. We passed it a reference to a function, and we can call that function. And we gave it the array of all those products that we created. It's three things, exactly what we would expect. There's nothing else in here. We didn't give it any other properties, but if we did, they would also show up in here. And then we printed out those exact things that we had. We printed out the function, say hello, and we printed out the array of things, which is over here. And then the last thing that we printed out was a property that is not in that object and it's undefined. If you try and access a property of an object that does not exist, then it's going to be undefined. And I'll get an error if I then try and do something with it here. That's invalid. Cool. So we got this. We don't actually need say hello, so I'm going to get rid of that. And now this is a valid React component. I'm just going to replace this with props.products and we'll be good. Actually, no. So there might be a couple different ways that you see properties in examples, or if you're on the internet. This is the easiest way of doing it. This is like the most basic way. You have an object, you just take out all the properties you want, put them in a variable, use the variable, or just use it directly like we just did a second ago. There's a really cool thing in JavaScript called object destructuring, which says if I have an object here, I can get a set of values which correspond to the keys of this object. So if you'll remember this object, our props object, we passed it a products value. And this is an array of objects. So I can say, take all of the keys that correspond to the names of what I put in here and give me the value as a variable. That was really confusing, but essentially we're saying take the value of props.products and put it into this variable, which we're calling products. This has to be the name of what you expect to be in the object. And if it exists, it will assign the value to that variable. And so now if I do console.log products, we'll take this out. This should be products. Oop. Well, so that variable now holds specifically that value from the object, which is the array of data objects. So this is destructuring. You could do this with a lot of different properties at once. And it's just a shorthand of taking them all out and putting them into variables. You might also see people just do this directly in the parameter up here. This is exactly equivalent to this. They mean the exact same thing. This is the syntax I like using because it's the most concise. This is saying my object, destructure it into a bunch of variables. And the only variable that I'm pulling out is the products variable. So this also works without any errors. All right, questions about properties before we move on to something else. It looks really gross. Ignore that. We'll make it prettier.
Yeah, but I didn't see the products. What is it? We just created the dummy data.
Yeah. So products is a property that I passed to this component. So again, up here,
Did you create another like component, like folder?
products
Yeah.
is just an array of data that we created in another file here. This is just an array. It has a bunch of JavaScript objects in it. And then
Yeah, but the variable name is the dummy data. How it's gonna be happen? It's like products.
it's products because in my app component, I've taken this dummy data and I've passed it to the property products. So this is just a key on that object, props. And the name of that key is products, which is why
It can be any name.
you can pick any name you want. You can make as many properties, as few properties as you want. If you don't have any properties, you can just completely omit this parameter up here. You don't have to put a properties object if you're not going to actually use it. But you can name it whatever you want. We could call this foo and give it a string bar. We could give this a value like my name. You can make any properties you want, any name you want. It's just a way of passing data down to a child component.
So basically, does it mean that you can avoid line 6 and just in line 14 put instead of data dummy data?
Exactly. That also works, and that's a lot more concise. That's a great point. So this dummy data is an array. We're importing it, and then we're using it directly as the value which we're passing into products table. I could call this dummy data as well if I want to. Generally, you'll see people pass a variable that's the same name as the property, just so that it's clear that it matches up and you only ever have one naming scheme for this data. If I don't do that, then in my app component, anytime I want to reference the data, I have to remember that it's called dummy data here. But then inside my products table, where I'm also using that data, I called it products instead, because that was the name of my property. So generally, we probably want to keep it consistent, but in this case, we're not going to. We're just going to reference it as products. This dummy data is named so that we specifically know it's not real data. It wasn't pulled from a server anywhere. We just hard coded it. Eventually, this will get replaced several weeks down the line. More questions?
Thank you.
All right. Let's move on to state, which is the other big thing that is important. So another thing we said we wanted to do in this project, we did this. I don't know how to make a check mark. So we'll just annotate it as done. We created our dummy products, we showed them in our table, and the last thing we need to do is add a search bar. So when I search for some fraction of a string, maybe I'm searching for just the string OL, I would expect that to pull up the olive product and not anything else that doesn't have OL in the name. So that's what we're going to do here with this search bar. And again, I could write my search bar right here and I could do some cool stuff. And I could, add all of my data up here and interactions and whatnot. But this is also something that should be its own component. Partially because it's one thing, again, it has a rendered output. It has behaviors associated with it. I should be able to submit my search, stuff like that. That should exist only within the search bar. But also, we might want to use this search bar somewhere else in our app on a different page. We're not just going to be searching for products. Maybe we have a different page where you're searching for, I don't know, instead of searching for food, you're searching for clothing or something like that. We want to use it on other pages. In that case, we want to only write our code one time and give it a firm set of behaviors. And then we can use it everywhere else in our application with just 1 or 2 lines of code. We can reuse it over and over. That's partially the reason why we would extract something into a component. So let's do that. Let's create a search bar component, which doesn't exist right now, so we got to do that. This folder is throwing me off. So we're going to delete it. Okay. Go to search bar. We're making a component. It's going to return something. Right now, it's going to return nothing. Going to export that component, which means we can use it somewhere else. And we're going to prove that it works by going back into our app. And we're going to use that search bar component. And right now, we haven't declared any properties to pass to it, so we're not going to do that yet. All right. So we got a search bar. It's in our page now. It doesn't look like anything. Right now it's just text to do. So we gotta fix that. So inside of a search bar, which we're going to surround with a div just so that it's its own box of content, I would expect an input element with type text, which means I can type into this input. I would expect a button, and this button should have text on it that says search. And what does this need to do? This needs to, when I hit the button, filter my products so that only names containing the search text show up. This is what we're trying to accomplish here. So there's a couple different ways of doing this. One way is by handling the event. So what I could do is add an onSubmit property here, which says when this input element is submitted, we're going to call a function up here, and maybe this function is handle submit, and we're going to do something. We don't know what that is yet. The React way of doing this instead is by controlling the input text manually. So if we did it this way, we don't know the text that's in this input until it's submitted at the very end, which is fine. In this case, that would work. But rather, what we want to do is we want to create a controlled component, which means I'm going to store the data that's inside this input search term, and this will start as an empty string. We're going to do some stuff with this. And I'm going to set the value of this input, the text that's inside of it, to be that search term. It's always going to show the exact same thing. So if I do this, oops, I gotta declare this. I can't type into the search bar because the value every time this form renders, we set to be an empty string. No matter what happens, it's always going to be an empty string. You'll notice that this is already trying to tell us what we're doing. We need to handle the change event on this input. So when I change the content of that input, it can let us call a function and do something with that data. And essentially what I want to do is when that change happens, it's going to call a function for me. And let's create a function up here, handle change. This is also to do, currently it doesn't do anything. But when this event is called, it's going to call this function that we're giving it a reference to. Again, we're not calling the function right here. We're just giving a reference to where it exists in memory so that under the hood, when this input changes, it can call the function with the new value. So these have an event parameter, and we can get the new value from event.target.value. Search term is equal to that. So we might think this would work. On this change, it's going to get the value of the new thing. And then it's going to assign it to search term, and that search term is our value down here. So this should work, right? No, still doesn't work. Every time it shows that our new term is the letter that we just typed in, but it doesn't ever update this blank up here. Does anyone have an idea of why that is? Any thoughts?
Because we are not changing the state of the search term.
That's where we're going. Yeah. If I were to change this value, what's the only way that this will be rendered to this input? So this value, we're going to change by assigning it a new value. Is it going to re-render our component by calling this function again?
No, I think no.
Yes, the answer is no. We don't have any way right now of re-rendering this component. The only way that our component is going to change how it looks on the screen is if our component gets re-rendered by calling this function again. We can't call this function. React has to call this function, and we need a way of telling React that this piece of data has changed, and therefore it needs to re-render because that is a component. It's an important piece of how our component looks. We use it down here. We want to set the value to whatever search term is. So every time that changes, we need to tell React, re-render my component, call this function again. We're going to put a new input on the screen that has this value instead of the old value. And the way we do that is by using state. So state is a piece of data that belongs to this specific instance of a component. When the component is created, it creates its state as a bunch of default values. You can modify that state, which belongs to that exact React component. And every time you modify the state, React says, ooh, this component has changed. I should re-render it so that if that state is used in the output is updated. And the way we do that is by this thing called a hook. This is a use state hook. And I'm going to just write some code here and then explain it after. Make sure we import it here. And let's see if this works. Great. So now I've updated the value. It re-renders my input with the new thing that I type in there. And then we can type more things and it builds it up over time and we can see this. So why does this work? This works because useState stores a singular piece of data somewhere behind the scenes that we don't have access to directly for this component. And that piece of data has two things. It has the actual data, which is returned as the first element. This useState returns an array of two things. The first thing it returns is the data, and then it returns an updater function or a setter function or whatever you want. We'll call this setter since the convention is usually set whatever the name you have here. So this is a variable. This is a piece of data. We're doing array destructuring, similar to how we did object destructuring earlier. This array has two things in it, and we're saying take the first thing, put it into a variable called search term. Take the second thing, put it into a variable called set search term. That first thing is the data. The second thing is the setter function. And now we can use whatever the current value of this state is by referencing this variable, which we use down here to set the text that's inside of our input element. And we use the setter function anytime we want to tell React this piece of data is changing. So set search term gives it a new value for that data. React stores it under the hood, and React says, oh, they called the setter function. I need to re-render this component. So we called this function ends. React goes behind the scenes, updates the piece of data, and then says, this has changed. I'm going to re-render that specific instance of the component, which just changed its state. By calling the function, we get the new value because it goes under the hood to grab the value in the setter function again. This value is now different because we used the setter function in the last call, and then we set the value down here. Is that clear? Questions? Okay. Let's look at a couple of pitfalls really quick. So let's say I didn't know that I needed to use this setter function. Let's say I set the new piece of data directly. We might expect that this would work. In the end, our function is just updating the data, so we could just update the data ourselves, right? We can't do that. We can't update that piece of data, which I made a constant, so that's one reason why we can't do it. But even if it wasn't a constant, which means in theory I should be able to update it, it doesn't. React doesn't know that that state has changed until you use the setter function, which under the hood updates the data. Okay, let's do another thing. We're going to set a click handler on this button, which means when I click this, it should do something. And we're going to get a random number. And this is going to be math dot. And so it's going to be a random number between 0 and 1, and we'll multiply it by 10. This is a fancy way of saying, give me a number between 0 and 9. And we're going to add another piece of state here. We can have as many pieces of state as we want. React will never confuse them because it records the order in which you do this use state and says, the first time you call use state when this component is rendered, it's always going to get the first piece of data, which is consistent. And the second time I call use state, it's going to get the second piece of data and stuff like that. So we're going to call this obj and set obj being short for object. And this is going to be an object that says my number is equal to 0 by default. So this thing in here is the default value. When I first render this component to the screen, whether it be when the application loads up or for some reason it was off screen and then we moved it on screen later, this data doesn't exist because the component didn't exist. So there is no previous version that it can pull from. And so it's going to set it to this default value instead. Every other time that data already does exist. And so it's going to return that instead. So let's say when we click this button, I want to update my object and my number is going to be random number. And let's add some text in here that says your random number is obj.myNumber. So let's see what this does. So my random number is 0 every time that this component re-renders. Oh, let me go fix this really quick. In general, we want to make our state constant so that we're not tempted to update this value accidentally, which we did. So we're going to get rid of this, bring this back. Cool. So now this should be fixed. And our random number is always 0, even when I hit search. Oh, I was trying to update my object. We're going to leave this as a let. No, we're not. We're going to say object dot my number is equal to random number, which says take the object, set the key my number to be whatever this value is. We're going to log.
Eli, you're not doing anything with set object.
Yes, we're going to do that very shortly, but I want to show the full range of all the wrong things to do first. You're way ahead of me though. Random number. Random number. All right, now let's see what this does. So I can search, it will generate me a new random number every time. You'll see that this is not updating because we haven't called that setter function. So again, if you just update that value, React doesn't know that it hasn't changed. So now we can set our object to be that same object with an updated value. This should work, right? We updated the property. It has something different to it. React under the hood surely will notice that it's a different value and will update our component. So we're going to log what the number was before we updated it, and then we're going to log the updated version of the number and go from there. So it starts at 0. The previous number was 0, the new number is 6, but it doesn't update, even though we called our setter function down here, set object. Now, if I click it again, you'll notice that the number is 6, so it did update in that object, even though our component didn't re-render, and now it's 4. And then it's 4 again, and so now it's 9. And we search again, and it was 9, and now it's 0. So our property is changing on this object. And if I were to have other handlers, it would actually recognize that there's a difference on this object here. But it's not causing our component to re-render, which is what we really want. The reason is if you are updating a state value that is an object or an array, must have a new object or array. It can't be the same one with modified values. It has to be a new object or a new array, which JavaScript will recognize as different, and it will then cause you to update your component. So I could say, let new object equal to an object with my number set to random number, and then new object down here. And now if I do it, our number is updating because we gave it a new object and React notices this is a different value and it causes our component to rewrite. So this is what we would expect. We can shorthand this by, instead of assigning it to a variable, we'll just put it directly into the setter function. Something else you might see fairly often, let's give it some other properties here. Zap, how. If I were to set a brand new object here, those other properties are going to be lost. And let's say I want to preserve them because they're not changing. I could do foo equal to object.foo and so on and so forth. But if I have a lot of properties, this is not sustainable and it's just really slow. So instead what we do is we say, spread out my object, which means take all the keys and values and assign it to this new object, and then overwrite my number with random number. And so now this will always be the same, and we can still update here. All right, I threw a lot at you guys. It's 8 o'clock. I am here for as long as needed to answer questions. If you don't have any questions, thanks for being here. Make sure you fill out your attendance form on the way out. I'll post it one more time in the chat. For anyone who didn't get to it, this is how I take attendance for my sessions. So make sure to do this before the end of the night. I'll probably submit attendance tomorrow morning.
I have a question. When in use state you used curly braces to mention those properties, my number foo, why you used curly braces? Because it's object?
Exactly right. So this state up here is a string. It should always be a string. I should never set a different value that's a number or an object or an array or something like that. This state down here is an object. It should always be an object. It should always have the same properties. Those properties will just change. But because it's an object, we create the object using curly braces. It's the same as doing this. This also creates an object. We can set foo equal to 1.
I see, even if it's just one property there.
Yeah, this is just shorthand. We've just put it directly in one statement rather than putting it into a variable. So this is an object with 3 properties that each have a value associated with them. And this is the default object. When this component is first rendered, the object that is returned here for the state will be this default. And then every time I change it and this component re-renders, it's going to return whatever the updated version is.
Okay, thank you.
Other questions?
I have one. Maybe it's not totally related to this current lesson, but I've dug into a little bit in reducers. So like not use state, but use reducers. But I didn't catch like the point of usage. Can you please explain it, at least in like some words?
Yes, I will give you a TLDR for now, and we'll come back to it in a future week. I don't remember exactly which week it is. I think there's a week that talks about impossible state, which is when reducers come back up, and we'll actually use a reducer as part of this project that we're going to keep building. But for now, just a quick TLDR for anyone who is not quite familiar yet. A reducer is another hook. So a hook is just a function that React defines that lets us do something cool. This is a hook use state. I think next week we're going to talk about use effect. It does a totally different thing. Use reducer is also a hook. And what use reducer lets us do is combine multiple pieces of state into a single object and update it all at once. In general, you probably won't need this hardly ever. Like in this case, these 2 pieces of state are completely independent. My search term has nothing to do with this random object down here. And so those can update independently. That's fine. But in some very specific cases, you'll have 2 pieces of state that are completely related. And if you update only one, but not the other at the same time, it's possible you could have a moment where they become out of sync and it becomes impossible. That's what we mean by impossible state. So the example that we're going to do later on is if I have a table, if I go to Amazon here and I just like click on some random stuff. This is not helpful. Down here at the bottom, I have a list of all the different page numbers, and I can go between page numbers. But these page numbers are dependent on the number of products in my list. If I add more products or remove them, then those page numbers are going to change. And if I get to a point of where I remove a page and I'm on that page, well, one piece of state is probably what page number am I currently on so that we actually know which products we're rendering. And that could become out of sync with the total number of pages. So if I have 20 pages and I'm on page 20, and then I search for new things and there's only 18 pages, well, page 20 no longer exists. If I try to render all the different products on page 20, we're going to have some kind of error. It's going to break our site. So we would use a reducer to group pieces of state that are related, and we have to update them, what we say, atomically, which means all at once, they all get updated or none of them get updated. And then we use our reducer to say, when this happens, do this calculation and update our object, which has all of our different pieces of state, which might be our page number, our max pages, our products per page, stuff like that. These are all different properties that would be in this object. My states, dispatch, state update, use reducer. And this takes a default value, which we'll just say is an empty object, and a function, which takes our old state and a payload. I don't remember if this is exactly correct. And you do some stuff in here. And this usually looks like an if statement or a case statement where you check this payload and see what has changed. And if something, then we're going to return a new state object, which has all of our old state, but maybe changes one or two properties to be something else. And so all of this state still exists in one object, and everything that needs to change at the same time changes at the same time. In general, if I didn't use a reducer and I tried to store them in separate state objects, and I did this. Let's say this handler needs to update both of them at the same time, and we call set foo, and that's some new value, and we'll set bar. 99.99% of the time, this will be totally fine. But React doesn't guarantee that your state updates are going to happen immediately or in the order that you expect them to. These are executed asynchronously, which means it's not right away. It's not going to block my function from executing. I call set foo, I call set bar. This happens right away. It doesn't wait for these to finish because they cause our component to re-render. And so it needs to happen after our function finishes. So I can't do this if these two pieces of state depend on each other. And if I updated foo, but bar isn't yet updated as well, then it would break my site if it re-rendered. Both of them need to happen at the same time, while I need to use a reducer, which puts all of my state into one object. And then I can use all the properties of that object later in my function as I see fit. But I know that my values in that object will always be consistent and will always agree with each other because I updated both of them at one time in my reducer function rather than updating them separately like I did down here.
So like the only reason to use a reducer hook is just to make just to create a transaction, in other words.
Yeah, that's basically what it is. You're creating like a transaction that you're doing some behavior and it updates multiple things and then it's finished and it commits them to your state. Updates the whole object, it re-renders the component, everything has changed. Or if it fails and you return an error, nothing has changed.
Yeah, now like in terms of transactions, it's understandable for me.
Yeah, it's very similar to a transaction.
I have
like
backend background, that's why transaction is in my terms, and like that explanation that I've read, it was like in React terms, and I didn't catch it at all.
Yeah, that's a really good comparison that I will probably end up using shamelessly in the future.
Cool, cool.
It's
Thanks a
very
lot for the
similar.
explanation.
Yeah, we'll do it again in a couple weeks. We'll do this example.
I just like looked for what are hooks, like because we use it like use state, and almost everywhere I saw like use state and use reducer like explanation together in some way. That's
They're
why I
very
was
related.
curious about what is it, but didn't catch the point to use it. If we can do that through this function, like here, this handle
Yeah.
change.
Use reducer should be very rare and should be a last resort if you need it for a specific reason. 99% of the time you don't.
And I suppose it should be used only for like complex features. Like,
Yes,
not for
I would
simple.
generally agree. Most of the time, your state is independent. You don't care. You're only
Uh-huh,
gonna update like
uh-huh.
one thing. But if it's a really complex thing and you have data that depends on each other, you might need a reducer. There'll
By
be
the
a lot
way,
of things in React. There's a lot of hooks that are like useful for one very specific case that you might come across at some point in the future. But we probably won't do a whole lot of in this class.
By the way, do you know why it's reducer? Because like the word reduce, it's like decrease something. But why you state? It's like obvious reasons. But why use reducer?
That's a good question. I don't know.
Because it's not it's non-logic. Because like use state for managed state, it's like totally understandable and like logically, but use reducer
Yeah. I don't know exactly. There's another concept of a reducer function for arrays in just vanilla JavaScript, which is where you like build up a value as you move through the array. Like you do something on the first one, you return a value. You do something on the second one, you add it. You do something on the third one, you add it. And then in the end, you've reduced all of these different elements into a singular value through some operation.
Ooh, it's so complex.
Yeah, it's not exactly the same thing here, but maybe that's where it comes from. I don't have a better explanation, so maybe someone on
Yeah, I
Google
see,
can
I
help.
see. Yeah, it's maybe because of that I was so like
Yeah,
distracted because like you think usually about the function, like you state or use reducer, it's a function. So and like usually I prefer to name functions so they will be like self-descriptive. And like with use state, it works 100%, but with use reducer, what? And I just couldn't understand what is going on.
yeah. Yeah, I don't have a good explanation for it. Someone on the React team knows why it's called that, and that person is not me.
Cool. Any other useful hooks for us just to at least to keep in mind for future references?
We'll talk about some of them. Use effect is next week, which is super helpful. So I'll leave that one for now.
Okay.
I don't think we talk about use context at all in this class, although we might end up using it for a feature in the future for this project.
Context, you
some
mean
review week.
like internal context, the like external function context, global context, or it's not that context?
Yeah, it's essentially you're giving a value to anywhere in your component tree that wants to use it without having to pass it through that whole tree. So if I have a tree that's like 7 components long, so one component has a child that has a child that has a child that has a child, and I want to get data from the top to the bottom, that's really cumbersome to pass it over and over and over again. And so context lets us provide, not necessarily globally, because it does have a scope. You put that context in a component and all of the children of that component can then sort of subscribe to that value. And when it changes, it will update the component and cause it to re-render. So it kind of like skips the whole props passing thing. That's probably more useful. You probably only use it like once or twice per project, but you could use it to pass like a theme element. Like maybe my site is in dark mode right now, and so I pass a context that says, what mode am I in? I'm in dark mode, and when it changes, it passes light mode instead. And then all of my components can subscribe to that and say, oh, it's dark mode now, I need to change how I look. And it causes it to rewrite. Stuff like
So
that.
in this way, we will just increase performance because we won't use so much memory. Yep.
I don't know that it's even really increasing performance. I think it just reduces the burden of like pass a property, pull it out, pass it to a child. That child grabs a property, pulls it out, passes it to a child. And the amount of code that you have everywhere, I don't know what like memory footprint that has compared to use context. In theory, use context is only storing the data in one place, and then it calls a function, and somehow all of our children components listen to that function being called and then can grab the new piece of data.
Yeah,
So
I
there might
think
be some memory benefit to it. I don't know how strong it is. It's more from like a reducing the amount of code that you have to write perspective.
I think that like in a matter of memory, it could be not like more performant because if you just propagating like probes from parent to child, it's an object. Like in that argument, it will be an object, and objects should be passed through reference. So like it will be the same object all the tree long, like deep inside. So like the memory consumption should be the same.
Yeah, it's possible. I haven't looked into it super deeply, so I'm sure someone has a blog post on this. It would be worth looking into for sure. If you do find something useful, send it to me.
Yeah. I just like thinking about like in general, you know, how object works. It could increase performance if we use like functions inside that objects. And if you create a function inside object, it will be like copied, cloned for every object creation. But if we put it into a prototype, it will be only one function.
Yeah,
Usage.
it's
In this
definitely
way, it could be like more performant, but we don't use functions inside that props.
Yeah.
We?
You're kind of describing another hook that I think comes up at the very end of the course, which is use memo, which sort of allows you to compute an object inside of a component only once, and then only when certain things happen does it cause it to recompute that object. If that computation is really expensive, like maybe we need to like make a request to a server somewhere to pull down data and then do stuff with it, we only want that to happen like once. And then if we change like what we're pulling down, then we need to re-request it. But if we did that every single time that we rendered our component, then we're going to be making so many requests to the server. We're going to get rate limited. It's going to be all kinds of problems. So there are hooks that allow us to control that. That's where I think most of the performance optimizations come from, whether that be not making a request if I don't need to, or not recomputing a value if I don't need to, stuff like that. And those generally are controlled by different hooks, like use context, use memo, use effect, stuff like that. So I think you're right on track here.
Yeah. It's cool to know that there are such things that could help us to work around like performance, because like modern modern websites with a lot of JavaScript sometimes could be like nightmare for your web browser and your PC.
Yes, definitely worthwhile keeping in mind. A lot of stuff you do in React will be just fine as long as you're not doing anything objectively stupid. But there are a lot of great ways to optimize, which is super good to keep in mind. And I'm glad you're doing it already.
Yeah. Thanks for explanation.
You're welcome.
Cool.
Eli, I'm sorry. If there are no any other questions, can I recap on the easy one, which I addressed at the very beginning? Can you share my screen very quickly?
Yeah.
Go
Go for it.
Okay. Can you see my VS Code?
Yes, I can see it.
So basically, I followed the instructions. I went through the npm install. My cohort teammates recommended me to do actually both, to do the npm installation as well as do the extension as you showed. So I added ESLint Microsoft.
Cool.
So it's precisely as you showed. So it's enabled, I believe, right?
Mhm.
So I'm just trying to understand how visually, where is it? Getting confused with this. So basically, how do I see that it is working? Because I don't see any drastic changes. I mean, in comparison to Prettier, for example, when I run, it corrects my formatting and everything. But what is the result of ESLint, for example? Can you give me a short example? So if I start typing something, if it's underlines with red line, it means it's ESLint?
I think so. I think that's all ESLint really does. Don't quote me on that, but the whole point of ESLint is just to check that your code is valid, that you're writing. So that when you run it, you know that it's functional.
Right. I was trying to check like different videos on that. Some were showing that ESLint actually supposed to correct your code and actually update to correcting version of your code when you save it. And I don't expect that. That's why I was wondering whether my installed ESLints actually function properly. That was my question.
Yeah,
is there any way to check? No?
I don't know about correcting code automatically, other than like it'll give you suggestions when you're typing about completing a line and then you hit enter. That's all I know of. I don't have any specific examples that you can check here.
Like, for example, if I try to make a variable, how it's supposed to like show me just that it's underlying?
It depends on ESLint rules. You have a specific file for that rules, ESLint rc.cgs in the root folder.
Yeah.
Root folder.
ESLint.
Is it this one?
Yeah.
Here is a list of rules that ESLint will like keep in mind to check your code. So like if you want to, I understand what do you want to do, because I've done that like several weeks ago with the same reasons. You want to check if it works.
Basically,
so
yeah.
I need to just break a rule listed here.
The reason I got triggered by this allegedly easy question is just I saw how ESLint should work. It basically it could definitely help you correcting your code as you go. But in my case, it doesn't. So I was just wondering what I was doing wrong, because I installed everything and I followed the instruction and just not working. And it's been triggering me for the last couple of weeks.
What is done? What is don't work?
What doesn't work?
What
basically,
doesn't?
That's what I'm showing. For example, if I am trying to assign a variable, right? And like say add num, and I misspell it. So, okay, I mean, the fact that it's underlining, but I think it was underlining even before I installed ESLint, so it's not the thing. And when I have automatic auto saving, so basically it should, like if I try to like at what stage when I'm
have you added that to your VS Code config just to run ESLint on save?
How should I do that?
You need VS Code config setting JSON, I believe, or config JSON.
You mean
It's
package
it's
JSON?
a global JSON config for VS Code, not project.
I have vid config and
VS Code. All these files are related to the folder that you've opened in VS Code, and I'm talking about VS Code, soft VS Code itself. VS Code soft has its own config that is like could be shown in UI, but it is stored and could be edited in JSON file. So
Yeah.
you can go for file settings or properties. Do you have that?
Preferences and then
Not file, the icon VS Code icon at the left top.
This one?
Top at top.
This one.
VS Code icon left.
Oh, this one.
Yep. Does it work?
No, it's not
Is it
functional.
Windows?
I think
It's Windows, yes.
I think it's file
okay.
preferences and then settings is where you should be able to find it.
File
preferences.
preferences and
Yeah.
settings. Okay.
So what he's talking about is the workspace tab at the top. So there's two kinds of settings. So your user settings, which means like everywhere you use VS Code on your computer user, it's going to have the same settings. Workspace, specifically this project, and it saves it to a file inside of your project that you can then commit to your Git repository so everyone else has the same settings. So if you go into the workspace tab up there,
Workbench?
workspace, so a little higher, where it says user and then workspace right next to it.
Okay.
And then you change a setting in here. Maybe let's change autosave to on. I don't know if, and then after delay.
After delay.
That create it. Yeah. So now on your left-hand side in your file structure, you'll see that there's a folder at the top, .vs code. And then inside of that, there's a settings.json, which is exactly what he was talking about. And this is setting specific to the project. So
Okay.
you could turn on like format on save or linting on save. I think like the way that you can be sure that ESLint is working is by breaking a rule that you don't have disabled. So the one that comes up most often is if you try and use a property on the props object and you haven't told VS Code what properties are in that object. So if you go into your app.jsx for a second, and then on line 5, you add your properties object inside those parentheses. So we'll just call it props. And then if you try and do props dot something, doesn't matter what, just pull some value out of the properties object. I don't think it's going to work in there. It has to be outside of your return for it to be valid JavaScript. So let's do like props.foo or something. Cool. And then you highlight over that red squiggle. So this is going to tell you that ESLint just flagged this, which is the extension you installed, and you haven't validated that foo is an actual property in that props object. So this is one of many, many rules that ESLint is enforcing. You can turn this off, which is what I did during this instructions, by going into ESLint RC and setting that rule to be false. But when you hover over this red and you see that it's ESLint that's enforcing it, and then the name of the rule right afterwards in blue there, that's ESLint at work. And then if you want to disable that rule, you're welcome to.
Okay.
I don't think it's going to correct code for you that's wrong automatically. I honestly have not seen anything that does that. Maybe you could do that with like GitHub Copilot or something crazy. I think the most that
but you need to run a script for that.
Yeah, maybe that's it too. There's
usually it's not the safest option to do, especially on huge pull requests, like before committing a huge amount of code.
Yeah, that is something that happens pretty often.
Yeah, but formatting
script
is really great to have on safe. And by the way, formatting is done not by ESLint, but the prettier that is switched on
Yeah.
I see it at the bottom right corner.
Okay, thank you very much, Eli.
Yeah.
Anton, thank you.
Yeah, you're welcome.
All right. I'm gonna close the Zoom. Thanks, everyone. Have a good weekend. I'll see you next week on Friday, since it's July 4th on Thursday. So I'll see you next Friday.
Thank you, Eli. You too.
Yeah, have a nice weekend. Bye bye.
Night.